understand early on, let's try to get it resolved as quickly as possible so that you'll understand the other content that builds on it later. So without further ado, let's talk about monitoring machine learning models. So I've broken down my talk today into three major components, and you might notice that I keep coming back to the number three. My brain likes to structure things in triplets. So the first thing that we're going to be answering is the question of what. What is monitoring machine learning models? Then we're going to ask why. Why do we want to monitor machine learning models? And finally, we're going to talk about how. Now, normally I have a theoretical and a practical component to my presentation about how to monitor machine learning models. Unfortunately, just like Bill, I've had to switch computers in the last couple of days. My work laptop, which had all of my Python notebooks hosted on it, shut down and hasn't been able to come back up. So I've had to cut out the practical component of today's presentation, but hopefully the theoretical component is still valuable to you. And we'll talk through how one would actually go about monitoring a machine learning model. So without further ado, let's try to figure out what it is that we're talking about. What does it mean to monitor a machine learning model? And I think to really understand this, you need to understand the general space of machine learning engineering and all of the work that's being done to get real business value out of machine learning models. So the paper that really started this whole conversation is named Hidden Technical Debt in Machine Learning Systems. You might recall this paper. If you don't, it was a really prominent paper that Google put out. And the primary thesis of it was that machine learning models actually take a lot of instrumentation and a lot of extra work aside from just training and deploying the model itself. It takes a lot of other type of engineering tooling to get a lot of value out of your machine learning models. And I think they captured it best with this one visualization that I've taken a screenshot of and shared on my screen here. So as you can see, there's a lot of components to getting value out of a machine learning model. ML code, this little black box, is really a small fraction of the total amount of code that you need to write. And all the way at the end over here, we can see that monitoring is a pretty major component of that. So in previous presentations that I've given, I've talked about the machine learning workflow, which starts with exploring and preparing data, and then building and validating a machine learning model, and then finally deploying and monitoring a model. Now, this workflow, while it's a useful framework, honestly, it's a really big oversimplification. And the reason for that, the reason that it's such a big oversimplification is because it simply doesn't capture the depth and complexity of each of these stages. So rather than talk about data exploration and preparation, which by the way are very, very important things to do, they're like a huge part of the machine learning model lifecycle. There's an estimate that about 80% of data scientists' time is spent just cleaning data, let alone feature engineering. But in today's presentation, I really want to focus on these last two steps, building and validating the model and then deploying and monitoring it. And rather than using, this visual presentation that I made, I actually took a screenshot out of a blog post that I really liked called CD4ML, Continuous Delivery for Machine Learning. In Continuous Delivery for Machine Learning, the author, Martin Fowler, he breaks down the process into more steps than just build and validate, deploy and model. So I'm gonna explore his way of visualizing it so that we're all on the same page of what the machine learning workflow looks like. So the very first step is building a model, right? And in order to build a model, you need a couple of things. You need some training code, right? Probably written in R or in Python, maybe in Julia, or maybe even in C++ if you're really advanced, right? We also need some data. In this situation, we're going to be taking training data, right? Because we're training our model. And then the output of this training code and this training data is some candidate models, right? So we've trained a lot of different models, and now we can start to compare them side by side. So we take these candidate models and we apply this model evaluation and experimentation step, where we bring in test data, right? As hopefully we all remember, you don't want to be using your training data to test the efficacy of your models, because then you might be overfitting. You want to take some separate test data and test your models, testing them on their accuracy, their precision, the area under the ROC curve, the F1 harmonic mean, whatever it might be, right? Whatever metric you choose to use to evaluate your model, you extract that metric by evaluating your models. And then from there, you select one particular best performing model, or maybe an ensemble of multiple models. And from there, you need to productionize it. So what that means is you take this abstract concept of your model and you turn it into a production ready piece of code, right? Now, this piece of code needs to go through a testing process where it gets deployed within your larger application, right? You want to integrate it with the platform that you're using, and you want to run the various CI CD and all of the other components of deploying any piece of software. And then finally, once your model is actually deployed, you're going to start bringing production data. So this is the data that's actually being used to generate predictions in real life. And then you're going to monitor the results of the model and monitor the performance of the model on that production data. So this is very abstract so far, right? Let's be a little bit more concrete. Let's take the example of Netflix and their recommendation engine. So how would Netflix implement this workflow in order to develop a new recommendation engine that they use to serve movies and TV shows to consumers like us? So they've got some training code, right? Which is so the viewing history of people who have been watching TV shows and movies on Netflix already. Or I'm sorry, that's their training data. They've got some code that they write out. From having worked with a couple of people at Netflix, I know that they mostly are doing a lot of their ML in Python. So they write out some Python code in a Jupyter notebook, and then they train a couple of different types of models. They're actually very proprietary about the particular models that they use, but they have some models that they use. They compare these models against each other, and then from there, they need to take these models, put them through the whole deployment process, including training or including testing them, and then finally, their model is sitting in production and it's actually starting to serve recommendations to users like us. So that's the production data coming in and the results being generated from it. Now, one thing that I really like about Martin Fowler's representation of this is this constant loop cycle, right? Because monitoring and observability are really only useful. It's really only important to keep in mind to monitor your machine learning model if you're actually going to do something about it if it changes, right? And in the case of monitoring a machine learning model, the doing something is usually going to be training a new model. And I'll talk about why you'll want to do that a little bit later. But just keep in mind that ultimately monitoring isn't the last step. It's just the last step of this particular iteration of a cycle, because from there, the cycle begins all over again. If Netflix realizes that their recommendations aren't really driving people to click on a lot more videos, to watch a lot more movies or serials, then they're going to need to go back and build some new models to try to convince people to keep watching their shows. So that's kind of the high level overview of, what does it look like to train and then to deploy a machine learning model. But then let's dive deeper and very concretely and specifically into what does it mean to monitor an ML model. So I've come up with a very simple definition that I think pretty much captures the core essence of what we mean when we say monitoring an ML model. So it means creating and tracking metrics about the performance of a machine learning model in production, right? So we've got all the different components that we've talked about so far: machine learning, production, but then there's this question of metrics. And I've underlined it because I think there's a lot of value to be had by breaking down this concept of metrics into three particular metrics. There's the triplet again, right? So there's three particular types of metrics that I think are very useful for machine learning models, machine learning monitoring to capture and to visualize. So the first one is metrics about data that are getting fed into the model, which is sometimes referred to as data monitoring. So in the case of Netflix, that means tracking user behavior and tracking specifically the data that's generated through that user behavior in order to make sure that there's not some strange anomalies in it, right? So if all of a sudden people are starting to watch a new TV show a lot more, that's a big change in the data. And Netflix engineers and data scientists probably want to be aware that there's a major change in the incoming data like that, right? So that's data monitoring. Now, there's also prediction monitoring, which is monitoring metrics about predictions that are being made by the model. Let's say that Netflix all of a sudden starts recommending that everybody watch some very obscure Spanish TV show that people weren't really watching that much before. That's a pretty big anomaly, right? So it's probably pretty important that data scientists and engineers at Netflix understand, why is this happening? Why is there a change in the predictions that are being made by this model? And in order to understand why it's happening, first they need to understand that it's happening. So they need to be able to monitor the predictions being made by the model in order to be able to understand why those things are happening. Now, the third types of metrics, system monitoring metrics, are the ones that are, I think, least discussed in other conversations about monitoring machine learning models, but I think is super important. So when we think about a machine learning system, there's data coming in and predictions going out. And then we oftentimes think about the thing in the middle as kind of being a black box. But in fact, this black box is a piece of software. And that piece of software runs just like any other piece of software on some hardware. And monitoring that hardware, monitoring the amount of time that it's taking for the system to make predictions, monitoring the amount of CPU being consumed, the amount of RAM being consumed, is all really, really important in making sure that our model is still performant. When we talked about metrics a little bit earlier, we were talking specifically about accuracy, precision, R squared, whatever it might be. But another important metric to think about when you're training a model is, how long is my model going to take to make predictions, right? Google actually published a really, really interesting study that showed that if it takes more than a couple of seconds to load a web page, people are likely going to click away from it. And that matters in the case of somebody like Netflix, right, who generates on-demand recommendations for TV shows and movies and needs people to stay on their website to watch those movies. So as soon as somebody clicks away, because the Netflix model is taking too long to serve those recommendations, Netflix's revenue is going to suffer as a result. So system monitoring, I think, is just as important as data and prediction monitoring, even though it's not talked about quite as much. So we've talked a lot about what it means to monitor a machine learning model. And I think you guys will be able to pick up very easily why it's important to do so. But sometimes it's useful to make the implicit explicit and to talk through even, the obvious facts. So I've identified three primary reasons. I told you I was going to say three a lot. Three primary reasons why you should monitor a machine learning model. The first one is because there might be a difference between sandbox and production data. The second one might be that there are shifts happening in processes generating the data, and I'll talk about two specific types of shifts that might occur. And finally, we might have externalities affecting the system. So let's break down each one of these components, or each one of these reasons, and understand them a little bit better. So the first one is the difference between sandbox and production data. Now, those of you who have been working in machine learning and data science are probably aware that there can be a pretty significant difference between the data that we use for just training and testing our model and the data that we start actually using once we deploy our model. And sometimes this happens because data scientists get a little bit trigger happy. They're focusing really, really hard on improving the accuracy of their model, and they simply add in some extraneous data, or they add in some assumptions that they can't necessarily make about production data. But sometimes there's just genuinely a difference between the data that got collected in the initial period, in the initial data collection period, and the production data period. Very similarly, there can be shifts in the processes that actually generate the data, right? We have to remember, data is an abstract concept, but it's being generated by actual real world events, right? Actual user clicks, actual movement of goods, transactions, whatever it might be, right? So there are real life processes that generate the data, and changes in those processes affect the distributions of data, which in turn affect the performance of a model, right? We actually saw a huge example of this. Well, I want to say just recently, but at this point, it's been almost a year, right? When COVID happened, a lot of assumptions that models had made were proven to be not false in the past, but no longer relevant, right? All of a sudden, airline predictions proved to be way off course, right? Because way fewer people were actually taking flights. Similarly, a lot more people started ordering goods online rather than in person. So a lot of models that were trained on historical data weren't able to take into account shifts or changes in the processes that generated the data. Now, those are all examples of processes that are independent of the machine learning model, right? Processes where the machine learning model is simply learning from what's going on in the world. But there's also model affected changes in the real world, right? In the case of something like Netflix, they have to be very, very careful to take into account the fact that their model's recommendations are actually going to be affecting the training data that they will get on the next set of predictions, right? So when Netflix recommends a movie to me, I'm more likely to watch that movie than if Netflix hadn't recommended that movie to me, right? Unless I happen to randomly stumble across that movie, I probably wouldn't have found it. So Netflix's model actually affects changes to real world processes and thereby kind of infects their own model development process with some bias. So it's important to keep track of these model affected changes and to track shifts in the processes that are generating the data in order to understand when maybe it's time to retrain my model. Maybe it's time to find some new data to make my model be performant again. Now, finally, there's also externalities that might be affecting the system. And I think this is primarily important for system monitoring, the last of the three types of monitoring that I talked about earlier. So system monitoring is important because it lets us keep track of how the hardware is performing and how quickly the system is able to spit out predictions. But if the machine learning model is co-located with other types of processes, so if I've got one server that both serves the model, but also serves the end application to the user, when a lot of people start hitting that server, it's going to get overwhelmed and it's going to be challenging for the model to be able to make its predictions in a timely manner. So it's important to keep in mind any types of externalities that might be affecting the system. And that's another reason why it's important to monitor machine learning models in production, because of the potential impacts of externalities on system monitoring. I see some questions that popped up in QA, so I'm going to take a look at them. So going from top to bottom, the first question from Yingquang Li was, can you talk about baselining? How do you baseline your monitoring system when you monitor a machine learning model? Thank you. So that's a really great question. So generally the baseline is the performance that you saw when you were training it, right? So as we talked about, there's a couple of different metrics that you can classify, right? There's metrics around incoming data. So the baseline for that is your training data and your testing data. Then there's the baseline predictions that your model is making. And then it's a little bit challenging to create a baseline for monitoring the system in production, but you can take a look at the first week, whatever it might be. So hopefully, Inquan, that helps to answer the first question. The second question in the chat is, can you name some tools that you use to monitor a machine learning model? For example, if you work in DevOps to monitor infrastructure, you use tools like Grafana, CloudWatch, AppDynamics, etc. Can you list specific technologies and softwares? Thank you. Sorry, Bill, I see that you said you marked something for the last question.
No, that's fine. I just kind of dismissed it since you already answered that question.
Okay. Oh, I see. So yeah, I can click answer live. Nice.
Yeah.
So to answer,
go ahead. Sorry.
So Yingquan, I'm going to get back to this question a little bit later. That I actually answer a lot of this in my final couple slides where I talk about how to monitor a machine learning model. So then Chester has a question of, would you categorize concept drift as real concept drift and virtual drift? This is getting a little bit into the weeds of like data drift and phenomena that causes things like mix shift and changes in the underlying processes. But yeah, like there's a basic classification of sometimes the underlying processes actually change, which is real concept drift. And then sometimes there's virtual drift, which is just the instrumentation or some other, data related process captures a drift, even if there's not actual change in the real world data. Great questions, you two. Let me just hit that I have answered these guys. And then Joy Toy asks, that bias is the new real world. So why would Netflix want to change the model? The new reality is people watching a lot more Netflix. COVID is the new normal. So that's a really good question. And I think it's getting into the weeds a little bit. But one of the things that's important to keep in mind is that as we introduce machine learning models more and more into our operations, as we add them to more and more processes in the real world, the impact that they have continues to grow. And the example that I think of specifically with the bias that we're talking about, where a model, starts to get affected by its own predictions, isn't actually Netflix, it's YouTube. And you guys might recall that a few months ago, YouTube got under a lot of flack for continuously recommending this rabbit hole of extremist videos, both Islamist extremist and right-wing extremist within the US, these more and more extreme videos to users. Because it turns out that when the YouTube algorithm is optimized simply on getting people to watch more videos, it'll continue to self-reinforce this pipeline that moves people into more and more extreme points of view, into more and more extreme videos that causes them to get radicalized, right? So it's important to keep in mind that you're absolutely right? Like Netflix now has to, or like Netflix in your example has changed the behavior in the real world. So it's useful to know what the real world behavior is, but it's important to keep in mind that when real world behavior is affected by the machine learning model, we have a responsibility to make sure that the machine learning model is causing ethical outcomes. So that's the main thing to keep in mind. I think also, Joy Toy, I think maybe there's a little bit of confusion based on the COVID is the new normal. So when I talk about the COVID change, that's actually an independent change rather than a model affected change. So you're totally right that Netflix shouldn't want to change, or Netflix, should take into account the new normal of COVID when it's trying to generate a model. The problem is that you need to know when these independent changes have happened, right? You need to know that there's been a shift in real world behavior. That's, COVID is totally independent of what Netflix's recommendation algorithm says. So it's important to keep in mind that Netflix actually needs to be able to monitor changes in how its users are using the platform and react and respond to those changes when their machine learning models are no longer accurate. Okay, so I don't see any more questions in QA. Oh, I see there's a lot of stuff going on in chat.
I think there are one questions in the chat about, I'm not sure the context, but if you scroll up 5 or 6 that talk about annotate the prediction and human.
Yeah. Okay, great question, Win. So the question is, how about annotating the prediction, and what about human in the loops? So that's a really good point, and that's one of the challenges with tracking the performance of an ML model after it's gone into production, right? Because there's a lot of times where our training data had to be immaculately worked on, where it had to be manually labeled by some, some paid intern, or maybe there's like a software that you're using to label the data so that you can train your machine learning model on it. So what's important to keep in mind is that in order to be able to monitor the prediction accuracy, you do need to have some baseline knowledge of whether the predictions that you're making are accurate or not, and that you don't necessarily have that for production data. But you can actually monitor a lot of components of your machine learning model without knowing whether or not your predictions are accurate, right? If we go back to the 3 types of metrics, only one of them actually could possibly take into account accuracy, right? Sorry guys, clicked the wrong direction. So of the 3 types of metrics, only prediction monitoring can take into account whether the model's predictions are actually accurate. Data monitoring, for instance, doesn't require any kind of annotation, right? It's just bringing in raw, the raw independent variables of your model. Prediction monitoring can take into account the accuracy or whether the model is actually making the right predictions, but it doesn't have to, right? You can just look at the distribution of predictions without looking at the accuracy of predictions. And if you see a change in the distribution, you can make assumptions about changes, at least in the sense that maybe it's time to re-examine the accuracy of the model. So pay somebody to annotate some data again, and potentially retrain the model from there. And similar to data monitoring, system monitoring is totally independent of having accurate baseline data. Okay, so there's one more okay, so this is more of a statement, but I think it's really, really useful. Pedro Dominguez has a great TED Talk that reinforces this concept where AI is changing the world by their own nature. Context, the Netflix algorithm changing the behavior itself that becomes the new world. Yeah, so Netflix, YouTube, Twitter actually talks pretty extensively about this as well. They know that the algorithm that they use to recommend tweets affects which tweets actually become popular, right? So Twitter has to be really conscious of the fact that the data that they're using aren't independent of the model, they're highly affected by the model. So thank you for weighing in with that, and I'm sure that's a great TED Talk, SR. And I see one more thing in chat. And it's not a question, so I'm going to continue.
Okay, great.
Okay.
Yeah, just quick reminder, folks, if you have questions, please post to the Q&A. It's easier to manage and track. You actually can vote for the questions. If you post on the chat, make sure to select to all panelists and attendees so everybody else can see the messages. Again, if you prefer to speak to ask questions or even ask, the comments, follow-up questions, feel free to raise your hand. We can unmute you. Please go ahead.
Great. So we've talked about what, and we've talked about why. And now we need to answer how, right? And I think we were getting into this a little bit earlier in one of the first questions. So I can tell that you guys are really eager to understand how can we actually implement in practice these things that we've been talking about abstractly. So talking about how we can monitor a machine learning modeling system. Another really great blog post that I read in preparation for giving this talk is monitoring machine learning models in production. This is a really great overview of the general market of, just basically what's going on in this space. And the author has this really great visualization, which if you notice, isn't about monitoring machine learning models specifically, but just about monitoring systems in general, right? The monitoring systems need to have three primary components. One key component that powers the other two. So that first key component is processing and storage, right? We talked about monitoring machine learning models as having three kinds of metrics that need to be monitored. Well, these three kinds of metrics need to be able to be stored somewhere, and they need to be able to be processed somewhere. So processing and storage is a really key component, and that can be done by any kind of database at the end of the day. Now, in addition to processing and storage, another key component of the monitoring system is visualization, right? Because being able to write SQL queries and looking at our data in a tabular context can be somewhat useful, but as human beings, we respond really powerfully and we're able to pick up on trends and patterns in data very, very quickly if that data is visualized, right? So machine learning monitoring systems, or really monitoring systems in general, need to be able to have some kind of visualization on top of the processing and storage to allow humans to be able to interact with their data and to allow them to be able to understand and detect changes in what's going on in the metrics that are being collected and visualized. And then that's for human in the loop monitoring. It's also useful to have human out of the loop monitoring, which is alerting, right? Because at the end of the day, like having somebody sitting around constantly monitoring a dashboard isn't necessarily the best use of their time, which is why having a machine in the loop alerting system can be really, really useful as a way to alert a human being that there's been a change in the data. So they should come and take a look using the visualization component, and from there make whatever kind of changes they want. So again, this is pretty abstract, but a pretty useful breakdown of the three major components of a monitoring system. We've talked about monitoring systems in general. Now let's talk more concretely about monitoring systems and software that exists out in the marketplace. So I broke this down into two rather than my usual three categories: application-specific tools and general-purpose tools. So application-specific tools are tools that are specifically built for monitoring machine learning systems, versus general-purpose tools are general purpose and just built for monitoring any kind of system or application. So let's talk about application-specific tools. There's three basic people who are groups of providers for these types of tools. The first is cloud and machine learning deployment providers. So that's people like AWS SageMaker, GCP and Azure also have deployment solutions. And I would say that these tools provide a baseline level of ability to monitor machine learning models. They are really focused on the deployment, on the productionization of machine learning models, but they simply don't have the built-in tooling to get deep into a machine learning model. And they don't provide that much context in terms of visualization or in terms of alerting. The people who I think are really pioneering and making the best application-specific tools for machine learning models are startups. To name a couple, Superwise, Fiddler Labs, there's a few startups out there who are doing really cool stuff. And they'll generally combine monitoring machine learning models with explaining and interpreting machine learning models. So these startups, I would say, if you're looking for, specifically just a tool to monitor only your machine learning model rather than your application in general, I would recommend starting with these startups rather than starting with these cloud ML deployment providers like Azure or GCP or AWS. There's a more in-depth list of these startups in this blog post that I linked to over here, monitoring machine learning models in production. But again, to name a few, Fiddler Labs is one that I'm connected with, and they do really good work. And then Superwise seems to be doing really cool stuff too. And then I wanted to give like a little shout out for open source projects. Unfortunately, in this space, there just hasn't been that much solid work done from open source projects. Kubeflow, a Kubernetes machine learning workflow organizer, seems to be trying to move in this direction, though they're more of a general deployment provider for deploying machine learning models on Kubernetes, and they don't have that deep of monitoring capabilities. Ultimately, I think there's a lot of progress that can be made from open source projects. I myself am a very strong believer in open source, but we just haven't seen that much development being done in that space. So that's application-specific tools, the tools that are made specifically for monitoring machine learning models. But there's also general purpose tools, right? Tools that are made to monitor applications as a whole. And as we talked about, you can think of machine learning models as just another piece of software, just another piece of code that have the same requirements for monitoring as any other type of software or any other piece of code. So general purpose tools can be really effective at monitoring machine learning models while also being useful in that they can monitor the rest of your application as well. So for this particular type or category of tools, I've broken it down into just two categories: commercial vendors and open source projects. So there are a few commercial vendors in this space. Splunk, AppDynamics have been brought up. The one that I work for, Imply, isn't specifically built to be an application monitoring tool. We can do a whole range of different visualization and alerting and storage for a lot of different applications beyond application performance monitoring, but that's a component of what we do as well, right? There's a lot of great commercial vendors out there, and I'm happy to talk about this a little bit more in depth, although obviously I'll have some bias working for one of them, right? And then the other type of general purpose tool that we might see is an open source project. And one that was mentioned in Q&A a little bit earlier was Grafana, which effectively is just a visualization tool built on top of, it's just a visualization tool. Actually, the vendor that I work for can integrate with Grafana, and you can take data from Apache Druid and visualize it in Grafana if you want to, although we have our own visualization technology as well. So there's definitely a lot more open source development being done for these general purpose tools than for these application specific tools. But I would still say that the best results that you're going to see for general purpose application performance monitoring is from commercial vendors. And working for one of those commercial vendors, I have to say that we do a pretty good job of it. So to answer the question, how can I monitor an ML model? My answer is that you can monitor it with Imply. And this is where I'm going to take a little bit of a detour from the presentation to show you, I unfortunately don't have the whole workflow built out on this laptop because, again, I was having some laptop difficulties earlier this week, but I can show you how you could use a tool like Imply to monitor an application. So let's go to the Imply website, implysales.implycloud.com. I'm going to be showing you a particular Imply cluster where I have a few different demos that I like to give. So we can open it up. So under the hood, what's going on here is we've got a cluster in AWS that's running Apache Druid. And then on top of that, which is an open source project that basically acts as a database. And then on top of that, we've got a visualization and alerting layer named Pivot. Now, you might remember what I talked about earlier. The three components of a monitoring system are storage and querying, which is handled by Apache Druid, visualization, which is handled by Pivot, and I'll show you that in a minute, and then alerting, which is similarly handled by Pivot. So I don't have a monitoring machine learning model demo built out, but I can show you some of the visualizations that we can build using Imply and Pivot. So this is an anti-money laundering demo that I built out earlier. Unfortunately, my cluster's a little bit underperformant today, so it might take a couple of seconds to load up these 14 million events. Let's go a little bit further back, actually, and let's say that we want to look at a larger data set. So right now, we're only visualizing 14 million, but let's say I want to visualize something more in the range of like a billion events, or 430 million events. So as you can see, I've got all of these different visualizations available to me, right? And what I can do is I can sub-select and interact with my data in order to get better insight into the underlying processes going on in the real world, right? I can just drag and drop, I can slice and dice and zero in on more specific data in order to understand what's going on and in order to affect changes in the real world. So this is useful for monitoring a machine learning model because these types of visualizations allow me to understand what's going on with my model and allow me to change the model in response to that. Now, as I mentioned earlier, in addition to visualization, another key component of a monitoring system is alerting. And that's why we have this alerting feature built out. So alerts are really useful because they allow you to send an email or a webhook using, PagerDuty, Slack, whatever you want to use when data has some kind of significant change, when there's some type of anomaly going on within the data. So we can either set this to happen raw. So, in this situation, I have it set up so that I can alert if there's less than 121 of some particular event in the past hour. But I can also make it work on a comparison. So let's say I want to compare this hour to the previous hour. And let's say if there's a more than 100% change from the previous hour, I want to get an alert. I can set that up as well. So alerting is really powerful because it allows us to bring a human into the loop only at the point where there's actually some kind of change in the data, when there's some kind of anomalous thing going on in the data. So this is one of the reasons why Imply is really, really useful for monitoring applications in general, but also specifically for monitoring machine learning models. I'm going to take a look at the Q&A and see if there's any other questions. Okay, from Chester, any significant difference in your experience using Windows OS versus Mac OS for data science work, ML prototyping, deployment monitoring, et cetera? Good question, Chester. I would say for the most part, OS doesn't matter a ton for data science because usually the tooling is pretty comparable between the two of them. I prefer in general to work on Mac OS just because it's what I've been using professionally since as long as I've had a career. But I have a Windows computer for personal use because I like playing video games. So I tend not to do too much data science on my laptop, on my personal laptop that runs Windows, but I haven't seen too much, data science specific differentiation between the two platforms. Good question. And let me open up the chat to see if there's anything relevant. Great. Okay, so that's the presentation. I wish that I had had the ability to dive in a little bit deeper and give you guys more of a hands-on experience with what it looks like to build out a machine learning model and then to deploy it to production and then to monitor it. But hopefully you all found this chat to be useful. If you have any questions now, feel free to shout them out, ask them in Q&A, ask them in chat. I'll stick around for a few more minutes to answer any questions that anybody has. I'm going to send a link to my LinkedIn. Feel free to reach out to me to connect with me on LinkedIn if you've got any kind of questions about data science, about machine learning, if you're interested in taking a look at the Imply platform, or if you just want to beef up your LinkedIn network. But if there's no other questions for me, then we can just hang out.
Great. Thanks, Daniel, for the presentation and the Q&As. So we have a few more minutes. Anybody have questions? Feel free to either post in the Q&A, or you can just raise your hand. I can just unmute you to have an open discussion.
Yeah, that's a great question, Sean. So Sean asked in Q&A, naive question, but how does monitoring a tool actually monitor, or how does a monitoring tool actually monitor an ML model? So really, really good question. So the first step is metric generation, right? The ML model needs to output certain metrics, and those metrics need to get fed into the monitoring tool, right? From there, the monitoring tool will now be able to store those metrics in some kind of database. In the case of Imply, it gets stored in it gets stored in Apache Druid, and then users can interact with the data and thereby monitor the underlying application using some kind of visualization tool. So open source Grafana, Kibana, or in the case of Imply, Pivot. So that's fundamentally how monitoring a model would work. Good question, Sean. Ashwin asks, can we interact with the demo you showed? Where is it available? So I unfortunately don't have a publicly available version of the demo that I showed. But Ashwini, if you're interested in playing around with the Imply product, I'd be happy to schedule some time for us to talk, maybe 15 or 30 minutes later this week or next week, so that you can actually play around with your own data rather than just with the data that Imply has provided for you. So feel free to reach out to me on LinkedIn or over email, and I'll be happy to schedule some time for us to talk about a more in-depth demo.